Hello, today we're going to work on vectors. So here we have to make a scale drawing showing a force of 20 newtons pulling an object east and another force of 10 newtons pulling the object in the compass direction 150 degrees. That's another way of saying bearing. So we're going to have our east, and that's going to be 20. And then we have our 150, which is going to be 10. So we know that our east angle here is 90. And we know that our other angle here is 150. And what we want to find is the resultant, which is in between those going out. Now we know that we can make a parallelogram with those sides. So this is going to be 20, and this is going to be 10. And then what we can do is we can say, okay, if I know that this angle up here is 90 and that's 150, I know that this angle in here has to be 60. So in a parallelogram, opposite angles are equal, and adjacent angles, angles on the same side are going to be supplementary. So now what we have are two sides and an angle that we know. So we can use our law of cosines to find this unknown c. So we're going to say, okay, c squared will equal 20 squared plus 10 squared minus 2 times 20 times 10 times cosine 120. And we're just going to simplify this down. So we get 400 plus 100 minus 400 cosine 120. And we get c squared equals 500 minus 400 cosine of 120 is negative 1/2. So we get c squared equals 500 plus 200, or 700. We're going to take the square root and get the square root of 700, which is equal to 10 square root 7, because the square root of 100 is 10, and we don't know the square root of 7. And because we wanted our magnitude to the nearest hundredth, what we're going to do is we're going to approximate that and get 26.46. So our c is going to be approximately 26.46 here. And now we have to find our direction, which means the bearing here. So let's clean up this slide a little bit. We'll have a figure here, which is what we found. So again, we're looking for this bearing. We know that this is 90. We also know that this angle here is 60. And what we know is that the angle larger here is 150. So all we have to do is find this unknown angle here, because then we can add it to the 90 degrees to get our bearing. And we know that that angle is going to be equal to this angle down here, because it is parallel lines, and that's our transversal. So alternate interior angles are equal. So here we can use the sine law and say this is 120, because we found that last time. And all we're going to do is sine 120 divided by 26.45, and that's going to equal sine of the unknown divided by 10. So we multiply 10 sine 120 divided by 26.45. That's going to equal our sine x. And we know that our c, our 26.45, is really the approximated value of 10 root 7 So those 10s cancel out. And we know that sine of 120 is actually square root 3 over 2. And we have that square root 7 there still. And that's going to equal our sine x. So we just have to find the sine inverse of the value, square root 3 over 2 root 7, and that will give us our x. And when we do this on a calculator, we get x equals 19.1 degrees. So we know that this little angle here is 19.1. But remember that we wanted that red angle, the bearing of this line here. So we needed this angle, which we take our 90 degrees, because this is a right angle, and we add our 19.1 degrees to get a total of 109.1 degrees. And that is to the nearest 10th as our direction asked. So we found the resultant force vector. We used trigonometry to do so. We found our magnitude, which was 26.45 there. And then we also found our direction, which was 109.1 degrees. So I'd like you to try one on your own. Here you want to make a scale drawing showing a force of 30 newtons pulling an object east and another force of 22 newtons pulling the object in the compass direction 120 degrees. Draw the resultant force vector and use trigonometry to find the magnitude to the nearest hundredth and direction to the nearest 10th degree of that resultant. Good luck.